Hi. Um, it's There are a couple of things that I want to talk about, but recently I just realized that there is a new technology, not really new, but I see a lot of application ahead of that for something called event camera. Unlike frame-based camera, uh, these event cameras, there are plenty of useful application for them. And in this episode, I won't talk about event cameras, um, but I would like to talk about two functions that are very helpful for frame-based cameras to detect edges and corners. And why I raised this topic about event camera, because I think they are somehow connected. Later we will see in the next episode when I talk about event camera why I raised this topic. And today, I would like just to, or this episode, I would just like to talk about these these functions, and that they are well known for edge detection and corner detection. So one of them is this one, which called basically a Laplacian. In OpenCv, there is a function called Laplacian that you can implement a discrete analog of Laplacian operator. And it basically works based on Sobel operator. As you see, I hope that you can see this diagram well. Maybe I just a little bit change this to the right to let's see if you can now see it better. Yes. So as you see, I hope it's clear now. Just a moment. Yeah. So as you see in the left photo or diagram, and so this is the function. Basically, the series says that if you want to find an edge in an image, you have to compare the intensity changes. So, or jump, I would say. So the way that this algorithm works is tries to find a jump in a specific location in an image for a high variation of intensity. So there are two steps. One, there's a function which basically based on the variation of intensity, and we take from this variation of intensity um, we take a derivative, and if this derivative, as you see in the second diagram, this is derivative, and if we take a second derivative from this diagram, we will reach to such a thing, which the second derivative is basically zero. It means that at the upper side and lower side you see difference. So this is zero, and up and down you see differences in intensity. So this is the place exactly that the edges are located, and you can detect. Of course, this can unfortunately with this method sometimes it can happen in a very meaningless locations in an image, but you can probably solve this problem by applying some filter or something like that. But the idea is just variation of intensity and with the second derivative of the function. And because it's usually you have two each image has basically two axes, x and y, so you have to apply this function for both direction, x and y direction. And as you see in this Laplace function, the second derivative is both in x and y, and there is a plus so in between. So it should be considered in both direction. And this one is very helpful, this Laplacian, basically to identify the edges. I will run a code and we will see how it works by Python in OpenCv. And but before that, I would like also to explain the second function that is very also useful. And just a moment. I think I am actually just a moment. I hope that all right, this is the second one, and I hope that you see that as well. Okay, this one called corner Harris, it's a bit more complicated than the edge detection. The theory is basically was presented by Chris Harris and Mike Stephens in a paper called the combined corner and edge detection in 1988. So it's a very old technique to detect the corners. And this one, basically there is a cost function or a function that is represented here, and there are Windows functions shifted intensity and intensity. So you will use a lot of this function to the idea is to maximize this function to detect corners and maximize the second term. And by applying the Taylor expansion to the above equation using some mathematical steps, you can basically get a formula like that, and which has a weight matrix, and ix and iy are basically image derivatives in x and y direction respectively. And at the end it comes the main part, which basically it determines if a window can contain a corner or not. So R basically the determination of m minus k trace m square power square 2. So where this is the determinants of m and trace m and lambda a and lambda b, lambda 1 and lambda 2 are the eigenvalues of m. And basically they explain that in what situation lambda 2, for example, if it's lambda 2 is much bigger than lambda 1, is basically edge. If it is both of them are large and not maybe similar in the value, that so it's basically a corner. And if lambda 1 is much bigger than lambda 2, then we also again has an edge, otherwise we have a flat region. So this one also I would like to apply it and see in reality what it looks like to identify. For that I have run this code, which is written in Python, and I will show you. I hope that I can go to this one. This, yeah. All right, so as you see, I'm running now a code in Python, and this one basically the window on the left, this is a webcam that I'm using behind me. So this one is the real time of me. Top corner at the left basically is a corner or Harris corner detection algorithm that is running, and at the right there is also a window which detects the edges. The edges windows is actually quite I would say not so clear, but you can basically see the edges of the sofa and this myself basically as well. This is my hands, and you see that the edge detection is working fine. But the corner, it's very detailed, so there are lots of dots, and I think every corner somehow has a eigenvalue that actually is very bright. So I will test it. I would like to put basically this picture or my book which is Introduction to Modern Optics, in front of this webcam and see how it works. Let me just put it in front of that. So it was clear that the Harris, so the corner detection worked. I could actually see some corners from the figures that exist on the edge on the page, front page of the book. But for the edge detection, it was too dark. So I don't know why. What was the problem, or maybe it's not really optimal. But yeah, this was a short description of Harris corner detection algorithm, and also Laplacian function that exists in OpenCv. Okay, I hope that you enjoyed this guy and this one, and stay tuned for event camera. That's also very interesting. New technology that exists. I would make an episode soon about that. Okay, see you. Bye.